Drones: Roles of Material Science to its Composition and Evolution. Few years ago, drones were just an innovation. Early samples were built by companies and enterprising technophiles. Now drones have taken over the world, serving crucial roles in various sectors of the world. The amazing thing about this technology is that, as material and microcontroller technology keeps improving, its evolution will be beyond human imagination. By studying the way drones are designed and the substance they are made of, we can understand how this important technology developed, and get more information on how it could be advanced in the near future. Drones, or unmanned aeronautics frameworks, are the flying machine which flies by directing thrust downward from two or more motor-driven propellers. Automation controlling is performed remotely by radio waves or independently. Drones majorly consist of two systems: the movement, mobile system, and the control system. Drones must be able to generate enough upward thrust to overcome their own weight so that they can fly. Therefore, the selection of materials in a drone is influenced by minimizing the drone mass. The process of selecting materials and designing components to minimize the mass is called lightweighting. A detailed description of the various parts of a drone. Drones consist of different components working together and performing different functions. Selecting materials for each part, the material density is taken into account to minimize the weight and maximize performance. The frame. The important component of a drone is a frame, which ought to be light. It gives a drone its shape and holds all the subsystem in place. The most important material property for the frame is strength. While commercial drones can sacrifice some added weight in order to be more affordable, industrial drones prioritize performance. Therefore, a material which is high in strength is used. For commercial drones, thermoplastics such as variants of nylon, polyester and polystyrene are popular choices because they are inexpensive to make into complex parts. Thermoplastics also offer good strength and low density, with several types having tensile strength in excess of 100 megapascal and densities below gram per centimeter cube. Motors and propellers. The motors that drives drones are conventional electric motors with copper windings and permanent magnets. They establish the principal drive arrangement of a drone and are exposed to the most astounding burdens, consequently their toughness is essential. Motors can generate significant heat, so materials with high thermal conductivity like aluminum can be used for the housing to help cool the motor. The rotor blades rotates at high speed, so they tend to absorb the most wear and tear when a drone flies. Choosing an ideal rotor blade material is a matter of maximizing strength while minimizing weight. Some rotor blades are made from carbon fiber reinforced composites, yet, rotor blades are frequently damaged in high-speed impacts while spinning and replaced. Therefore, so many are made of thermoplastics to reduce the cost of replacing them whenever they break. Batteries. Improvement to battery technology might be the most important breakthrough that made modern multi-rotor drones possible. During the early stage of the development, batteries were a significant downside to the technology, since it is depleted following 15 minutes of flight, causing a declined drone on the ground. But currently, there is a significant improvement. The strength-to-weight ratio are considered when designing the battery. Battery performance can be measured in terms of the battery's weight. Measurements like specific energy and specific power describe a battery ability to store and release energy in terms of the battery's mass. Lead-acid and nickel-cadmium batteries weighed too much for a drone they powered to fly for long. However, modern lithium-ion batteries offer enough energy and power in a lightweight package to make multi-rotor drones possible. Technological advancement in batteries and capacitors technology will enable even lighter, higher performance drones. Sensors. Just like how the human body uses a complex network of senses and nerves to balance itself when walking, multi-rotor drones uses an impressive set of senses and feedback mechanism to stay in the air. The very important part of a drone's nervous system are its tilt senses. Joining a mix of gyroscopic senses and accelerometer, tilt sensor are tied into feedback loops with the drone's motors. A drone in flight constantly makes tiny change to motor thrust to remain level, allowing it to recover from air currents and extreme maneuvers. Drones can apply a variety of other sensors to monitor their internal system and the world around them. Current and voltage senses helps the drones to track the energy drawn from its power reserves, helping the controller know when it's time to land and recharge. GPS and magnetic sensor help in navigation by determining the drone's location and orientation. Airflow sensors helps drones to detect their airspeed or wind currents, and the information is fed back into its balancing circuit to make the drone's flight even more stable. Microcontroller and cameras, the same advancement in microchip technology that created the modern smartphone, makes it possible for drones to be flying computers. As drones get smarter, they are becoming capable of taking on more sophisticated tasks with less human control. Researchers are learning how to program drones to perform increasingly complex tasks without human help. Movie studios use high-end drones to shoot their big-budget movies. But advancement in the field of computer visions are turning drones' camera into more than just an aid for human pilot. The drones of the future will use camera to see the world around them and use that information to pilot themselves. Drones are becoming increasingly capable of flying without help from either a human pilot or even GPS to navigate. And this is giving rise to a powerful new capability: drones working together. Research has produced drones that use their own on-board sensors, and even their camera to recognize other drones and fly in formation. Soon, it will be common to see a team of autonomous drones acting as lifeguards, caring for crops or flying in search formation to aid disaster relief efforts. Because of the quantity of arms and the engines utilizes, the drones can be classified into different models as bicopters, 2 rotors, tricopters, 3 rotors, quadcopters, 4 rotors, hexacopter, 6 rotors, and octocopter, 8 rotors. Application of drones technology. In fire brigade, use for vision support in actions of fighting forest fire, air disaster, thermal detection of fire source, tracking and monitoring the sources of pollution. In police, can be used for patrolling a designated area, traffic congestion documentation and traffic jams, operating and monitoring of mass events.
We are going to
In fringe monitors, for observing the outskirt zones, discovery and checking of contamination sources, items, land and water fringe, following moving targets. In armed forces, for observation and reconnaissance zone, direct help for battling and preparing undertakings, directing the offer of knowledge. In synthetic industry, for observing, diagnostic and investigation of level gases discharge, exhaust and other unsafe or unwanted substances. Warm recognition of flame sources, checking of creation, innovation and calculated procedures. In geodesy organization, for quick perception and control of region, mapping etc. In promoting organization, used for sport, photography and promoting films. The utilization of drones on an expensive scale involves a high hazard. The primary risk is the fall of a drones from an incredible stature, which might be expected to. Evolution. Drones are now everywhere. They are shooting movies, helping to sell real estate, broadcasting sport, creating new sports, working at farms and factories, hunting other drones and also delivering packages. As material analysis and microcontroller improves, drone will continue to revolutionize a broad range of industries, and also revolutionize the way the world works and plays. The materials used in drones are selected to enhance performance with high-strength frames and high battery capacities while minimizing weights. Minimizing the drone's weight maximize their performance. As drones' development are constantly getting smarter, it may not be long before autonomous drones becomes an inherent part of our everyday life.